Hi everyone, Topic 10 Special Probability Distribution, Subtopic 10.1 Poisson Distribution. Learning outcomes. At the end of this lesson, students should be able to identify the Poisson distribution, identify the mean and variance of Poisson distribution, and use the Poisson distribution to solve related problems. In this topic, we are going to learn about three different types of distributions, which are Poisson distribution, binomial distribution, and also normal distribution. Poisson distribution is denoted by x tilde Poisson lambda. Poisson distribution is a discrete probability that is useful when n is large and p is small and when the independent variables occur over a period of time. For examples, the number of telephone calls per day, the number of patients arriving at the clinic in the first hour it is open, the number of misprints per page. It must satisfy the three conditions. The number of occurrences is a discrete random variable. The occurrences are random and independent. We are going to use this formula to find the probability distribution of x for Poisson distribution, where x is the number of occurrences, lambda is the mean number of occurrences, and e is the Euler's number, approximately 2.71828. For any Poisson distribution, the mean and variance both equal to lambda. For example, we were given x tilde Poisson 4, find probability x equal to 6. What we are going to do is, we are just going to substitute lambda equal to 4 and x equal to 6 into this formula. So we are going to end up with 0.1042. Remember that we can always use Poisson formula to calculate the probability. But imagine if we need to calculate the probability such as probability x less than equal to 5. In this case, if we use the formula, we need to do the calculation as shown below. We need to add up from probability x equal to 0 until probability x equal to 5 to find the answer. This procedure is time-consuming, thus it is easier to use the Poisson distribution table. But since we can only find the value of probability x greater than equal to a in the Poisson table, we may need to change the probability in order to use the Poisson table, such as when we need to find the probability x equal to a, we calculate it as probability x greater than equal to a minus probability x greater than equal to a plus 1. For probability x less than equal to a, it is equal to 1 minus probability x greater than equal to a plus 1. And for probability from a to b, it is equal to probability x greater than equal to a minus probability x greater than equal to b plus 1. For example, if we would like to find the probability x equal to 3 by using the Poisson table, we need to change it into x greater than equal. So it's going to be probability x greater than equal to 3 minus with probability x greater than equal to 4. This is because when we calculate the probability x greater than equal to 3, it means that we add up the total probability from 3 and above. And when we minus it with probability from 4 and above, what we actually get is probability when x equal to 3. The same thing goes to when we would like to find the probability for x less than equal to 3. So we need to change it into x greater than equal. It's going to be probability 1 minus probability x greater than equal to 4. This is because 1 means the total probability from x equal to 0 until infinity. And then since we like to find the probability for x less than equal to 3, it means that we don't want the probability starting from 4 and above. So we need to minus it with probability from 4 to infinity. So we get the probability that we want, which is the probability for x less than equal to 3. The same thing goes to when we would like to find the probability from 2 to 4. We need to change it into x greater than equal in order to use the Poisson table. So what we're going to do is, we find the probability for x greater than equal to 2, x greater than equal to 2, and then we minus it with probability x greater than equal to 5. This is because probability x greater than equal to 2 means that we add up the probability starting from 2 until infinity. And then, since we only want the probability from 2 to 4, so we need to minus it with probability from 5 and above. So we're going to left with probability from 2 to 4. Example 1. If x tilde Poisson 6, it means that our lambda is equal to 6. A. Find the probability x equal to 3. So we have two options to find the probability x equal to 3. The first option is we can use the Poisson formula, Poisson distribution formula, which is Px equal to x, e to the power of negative lambda, lambda to the power of x divided by x factorial, where x starting from 0 and above. So we are just simply going to substitute x equal to 3 and lambda equal to 6 into the formula. So we're going to get the answer is 0.0892. This is the first method by using the formula. The second method is to use the Poisson table. In order to use the Poisson table, we need to change our probability into greater than equal. So to change it, we use the formula here. For probability x equal to a, is going to be equal to probability x greater than equal to a minus with probability x greater than equal to a plus 1, which means to find the probability x equal to 3, we need to find the probability x greater than equal to 3 and then minus it with probability x greater than equal to 3 plus 1, which is 4. So Px equal to 3, it is equal to probability x greater than equal to 3 minus with probability x greater than equal to 4. So now we're going to learn how to use the Poisson table in order to find the probability x greater than equal to 3 minus with probability x greater than equal to 4. So look at the Poisson table and look at the specific value for lambda equal to 6. The upper part here is the value of lambda. Since our lambda is equal to 6, so we're going to look a little bit down. Find lambda equal to 6 here. Lambda equal to 6. And since we like to find the probability x greater than equal to 3 minus with probability x greater than equal to 4, it means that here we need to find the value when r equal to 3, which is when lambda equal to 6 and r equal to 3, the probability is 0.9380. And then we minus it with lambda equal to 6 and r equal to 4. which is 0.8488. And when you minus it, we're going to get the answer is 0.0892. For the next example, I'm just going to use the Poisson table since it is a lot more easier. So for B, to find the probability x greater than equal to 2, we can straightly look at the Poisson table since it is already x greater than equal. So just find the value when lambda equal to 6 and r equal to 2. Look at the Poisson table. Lambda equal to 6 here and r equal to 2. So the value is 0.9826. From the Poisson table, probability x greater than equal to 2 is 0.9826. Next, C, probability x less than equal to 1. So in order to use the Poisson table, we need to change it into greater than equal, x greater than equal. So look at the formula before. For x less than equal to a, it's going to be 1 minus probability x greater than equal to a plus 1. We need to plus a with 1. Thus, here it's going to be 1 minus probability x greater than equal to 1 plus 1, which is 2. And then we can look at the Poisson table, which means lambda equal to 6 and r equal to 2. And the value is going to be the same with B, which is 0.9826. So 1 minus 0.9826, which will give us the answer 0.0174. And for the last one, D, we'd like to find the probability from 4 to 5. Since I'm going to use the Poisson table, we need to change it into x greater than equal. Look at the formula before. So for probability from A to B, it's going to be x greater than equal to A minus with probability x greater than equal to B plus 1. B plus 1. So probability x greater than equal to 4 and then minus with probability x greater than equal to 5 plus 1. Remember, B plus 1. So 5 plus 1, it is equal to 6. Look at the Poisson table. When lambda equal to 6, r equal to 4, and then minus with r equal to 6. Look at the Poisson table. Lambda equal to 6, r equal to 4, 0.8488, and then r equal to 6 is 0.5543. So 0.8488 minus 0.5543, which was equal to 0.2945. Example 2, x is a discrete random variable with x tilde Poisson 2.4. It means lambda equal to 2.4. We need to find the mean, Ex mean. We know that for Poisson distribution, Ex, which is mean, is also equal to lambda. Thus, Ex is just equal to 2.4. Sorry, supposedly it is 2.4. And for the standard deviation, we know that the variance for Poisson distribution is also equal to lambda, which is equal to 2.4. But for the standard deviation, it is equal to square root of variance, which is square root of 2.4, which is 1.549. Example 3. Given that the random variable x has a Poisson distribution with mean 3.2. We know that Ex equal to mean and it is also equal to lambda. So for this example, our lambda is equal to 3.2. Or we can write it as x tilde Poisson 3.2. And we need to find probability x equal to 9 by using the Poisson distribution table. So probability x equal to 9. We need to change it into x greater than equal. It's going to be x greater than equal to 9 minus with x greater than equal to 9 plus 1, which is 10. And then just look at the Poisson table. And you're going to get the answer is 0.0057 minus with 0.0018. Make sure that you look at the Poisson table with lambda 3.2. And for B, we need to find the value of R if probability x less than equal to R is equal to 0.9554. So in order to use the Poisson table, we need to change it into x greater than equal. So for probability x less than equal, it's going to be 1 minus probability x greater than equal and R plus 1, which is 0.9554. Rearrange until probability x greater than equal to R plus 1 is the only one left on the left. So 1 minus 0.9554, we're going to get 0.0446. And lastly, we are going to look at the Poisson distribution table to find the probability 0.0446 and lambda equal to 3.2. So look at the Poisson table. Look at the Poisson table. Lambda equal to 3.2 here, right? And find the probability that 0.0446, which is here. So we can write that probability for x greater than equal to 7 is 0.0446. From the Poisson table, probability x greater than equal to 7 is going to give the probability 0.0446. So to find the value of R, we just compare. It means that R plus 1 equal to 7. So R equal to 6. Example 4. A sales firm receives on the average 3 calls per hour on its toll-free number. For any given hour, find the probability that it will receive the following. First of all, we need to know that whether the question follow Poisson distribution. The hint that it actually follow Poisson distribution is that it has per hour. Per something means the distribution follows the Poisson distribution. Since we're given average 3 calls per hour, it means that average is actually equal to mean, which is equal to Ex equal to lambda. So lambda is equal to 3 for this question. We can write it as x tilde Poisson, since it follows Poisson distribution, and lambda equal to 3. We would like to find the probability that it will receive at most 3 calls. At most 3 calls mean x less than equal to 3. So there are two options. We can use the formula, or we can also use the Poisson table. So to use the Poisson table, we need to change it into x greater than equal. So for x less than equal, it's going to be 1 minus px greater than equal to that value plus 1. So going to be 1 minus probability x greater than equal that value plus 1. So 3 plus 1 is equal to 4. When we already change it into greater than equal, we can just simply look at the Poisson table, but specifically look at the value for lambda equal to 3. Lambda equal to 3 and r equal to 4. Then you're going to find that the value is 0.3528, which is 0.6472. The same thing goes to the second one. We like to find the probability that it will receive at least 3 calls. At least 3 calls means it must be x greater than equal to 3. In order to use the Poisson table, it is already x greater than equal, so we can straightly look at the Poisson table for lambda 3 and r also equal to 3. So you're going to get the value is 0.5768. And for the last one, we need to find the probability that it will receive 5 or more calls. It means that x greater than equal to 5. Since it is already greater than equal, just look at the Poisson table when lambda equal to 3 and r equal to 5, and we get the answer 0.1847. Example 5. The number of accidents occurring in a factory each week follows a Poisson distribution with variance 2.8. We know that variance for Poisson distribution is equal to lambda, so it is equal to 2.8. We can write it as x tilde Poisson, since it follows Poisson distribution, and lambda 2.8. And this value of lambda is happen for each week, per week. 2.8 per week. A. Find the probability that no accidents occur in a particular week. No accidents mean probability x equal to 0. So to find the probability x equal to 0, we can use the Poisson table. If we would like to use the Poisson table, it's going to be x greater than equal to 0 minus with probability x greater than equal to 1. But you can also use the Poisson distribution formula, which is e to the power of negative lambda, lambda to the power of x divided by x factorial, which will give you the answer of 0.0608. Next, B. Find the probability that less than 3 accidents. Less than 3 means x less than 3. If we would like to use the Poisson distribution formula, we're going to add up x0 plus x1 and probability x equal to 2. We need to substitute into the formula like this and then add up all 3, and we're going to get the answer. But if we are going to use the Poisson table, we need to change it into greater than equal, x greater than equal. But since we have here x less than 3, So before we change it into x greater than equal, we need to change it into x less than equal first. Since the formula that we're going to use, it only shows the value for when x less than equal to a. So we need to change it into less than equal first. So for x less than 3, it means that x less than equal to 2. Less than 3 means until 2. So change it into greater than equal in order to use the Poisson table. Then it's going to be 1 minus probability x greater than equal to 2 plus 1, which is 3. Right? And then look at the Poisson table, and you're going to get the answer is 1 minus 0.5305, which is 0.4695. C. More than 4 accidents occur in 2 weeks. More than 4 means probability x greater than 4. In order to use the Poisson table, we need to change it into greater than equal. So change it into greater than equal. So greater than 4 means 5 and above. When we change it into, since we already changed it into greater than equal, so we can just look at the Poisson table to find the value. But we need to find the probability that it occur in 2 weeks. 2 weeks. So our lambda is not going to be the same with 2.8. It's not going to be 2.8 because 2.8 is the average or variance for 1 week per week. So for 2 weeks, our lambda is going to be 2 multiplied with 2.8, which is 5.6. So for C, we need to write it as x tilde Poisson, and lambda is 5.6. Look at the Poisson table. Find lambda equal to 5.6 here, and then r equal to 5, r5, so here 0.6578, 0.6578. And then the last one, exactly 6 accidents, probability x equal to 6, occur in 2 weeks. It also means that lambda equal to 5.6, x tilde Poisson 5.6. You can use the Poisson table, or you can just use the Poisson distribution formula. I'm going to use the Poisson distribution formula, which is e to the power of negative lambda, lambda to the power of x divided by x factorial, which will give you the value of 0.1584. Example 6. The average number of cars which stop at a petrol station is 36 per hour. By assuming that the number of cars which stop at the petrol station follows a Poisson distribution, find the probability that A. No cars stop at the petrol station in an interval of 10 minutes. So first of all, we are given that the average, which is mean, which also mean EX, equal to 36, but this is for per hour, 60 minutes per hour. We can write it as x tilde Poisson 36, right? And then we need to find the probability that no car stop at the petrol station in an interval of 10 minutes. No car mean probability x equal to 0. But since the interval time is just 10 minutes, so we need to find the new lambda for 10 minutes. In order to calculate it, we need to divide 36. The new lambda is going to be 36 divided by 60. When we divide 36 by 60, we get the lambda for 1 minute and then multiply it with 10. So we get the new lambda for the interval of 10 minutes is equal to 6. So x tilde Poisson 6. Right, and then you can decide to use the Poisson distribution formula or to use the Poisson table. I'm going to use the Poisson formula, which is e to the power of negative lambda, lambda to the power of x divided by x factorial, which is 0.0025. Next, B, find the probability that more than 3 cars. Probability x more than 3, but in the interval of 20 minutes. So we need to find the new lambda. Divide 36 by 60, so we get the lambda for 1 minute, and then multiply it with 20. So we have 12. Write it as x tilde Poisson 12. You can use the Poisson distribution formula or use the Poisson table. I'm going to use the Poisson table. So in order to use the Poisson table, I need to change it into greater than equal. So greater than 3 means x greater than equal to 4 and above. Since I already changed it into greater than equal, I can just look at the Poisson table. Lambda equal to 12, r equal to 4. Lambda 12, lambda 12, here r4, so the probability is 0.9977. 0.9977. Example 7. Assume that the average number of computers sold at a shop per week is 4.53. Find the probability that more than 2 computers are sold in that shop per week. We know that it follows the Poisson distribution since we're given per week in the sentence. So we can write it as x tilde Poisson lambda. Average equal to 4.53. It means that our mean or lambda equal to 4.53. We are needed to find the probability that more than 2 computers. Probability more than 2. As usual, there are 2 options to find the probability. We can either use the Poisson distribution table or the Poisson distribution formula. I'm going to use the Poisson table. So in order to use the Poisson table, I need to change it into x greater than equal. X greater than equal. So x, the integer that is greater than 2, starting from 3 and above. After I change it into x greater than equal, I'm going to take a look at the Poisson table when lambda equal to 4.53 and r equal to 3. But then, when I look at the Poisson table, it only has the value for when lambda equal to 4.5. It doesn't have the lambda equal to 4.53. When this kind of thing happen, it means that we cannot use the Poisson table to find the probability. Instead, there are no other option. We still need to use the Poisson formula, Poisson distribution formula. Cannot use Poisson table. Right, so need to use the formula. To use the formula, we are needed to find the probability x more than 2, which is x greater than or equal to 3. So to use the formula, we need to calculate the probability from 3 until infinity. But this is impossible. So instead of finding the probability starting from 3 until infinity, we reverse the process. We calculate it as 1 minus something. So since we would like to find the probability starting from 3 and above, the values of x that are not included are x equal to 0, x equal to 1, and x equal to 2. 3 and above means we excluded the value for x0, x1, and x2. Right? And then we substitute it into the Poisson distribution formula, which is e to the power of negative lambda, lambda to the power of x divided by x factorial. And then the same thing here, e to the power of negative lambda, lambda to the power of x divided by x factorial, and also e to the power of negative lambda, lambda to the power of x divided by x factorial. Calculate everything and you're going to get the answer is 0.8298.